Today we're going to discuss solving exponential and logarithmic functions. An exponential equation is an equation containing one or more expressions that have a variable as an exponent. To solve exponential equations, you try one of two methods. Either try to make both sides of the equation the same base, or you take the logarithm of both sides. The first method can only be used sometimes. We have to be able to write both sides of the equation with the same base. You can't always do that, so sometimes we have to take the logarithm of both sides. However, taking the logarithm of both sides will always work. Even if you could use the first method, you could use the second method as well.
Our first equation we're going to solve is 9 to the 8 minus x power equals 27 to the x minus 3 power. So remember, our first technique was to try and set these to the same base. Both of these are powers of 3. So on this side, we have 9 is the same as 3 squared. And 27 is the same as 3 cubed. So now we can replace these. Instead of 9, we're going to write 3 squared. Instead of 27, we're going to write 3 cubed. So when we rewrite it, we get 3 squared to the 8 minus x equals 3 cubed to the x minus 3. Remember, when we have a power to a power, we multiply the exponents. So you get 3 to the 2 times 8 minus x equals 3 to the 3 times x minus 3. Now that we have the same base, we can get rid of the bases altogether and set the exponents equal to each other. So we have 2 times 8 minus x equals 3 times x minus 3. Remember, you can only cancel bases when they're the same. You can't cancel bases that are different. So now we distribute on both sides. 2 times 8 is 16 minus 2x. And over here we get 3x minus 9. Now we want to move the x's to the left and the numbers to the right. So we'll subtract 3x from both sides to get 16 minus 5x equals minus 9. Now we'll subtract 16 from both sides and get minus 5x equals minus 25. And for the last step, we'll divide both sides by negative 5. So we get a final answer of x equal to positive 5. And we can double check this if we want to by plugging it into the original. We can do 9 times 8 minus 5 equals 27 to the 5 minus 3. That gives us 9 to the third equals 27 squared. If we plug these into a calculator, we'll get the same answer. Both sides would be equal to 729. So we know that the answer works, and x equals 5 is a good solution. Now we're going to solve the equation 4 to the x minus 1 power equals 5. There's no way to set these equal to the same base, because 4 is 2 squared, and 5 can't be written as a power of 2. So instead, we're going to take the log of both sides. That was our second technique. So log of 4 to the x minus 1 is equal to the log of 5. Notice we're using the common log, which means that the base is 10, but we don't need to write the base when we use common log. Exponents can come out in front and be multiplied. That's one of our rules, our properties of logarithms. So we can have x minus 1 times the log of 4 equals the log of 5. Now we can divide both sides of the equation by log of 4, because log of 4 is just a number. So we have x minus 1 equals log of 5 over the log of 4. And then the last step is to add 1 to both sides. So you get x equals log of 5 divided by log of 4 plus 1. We can go ahead and put that in our calculator. Make sure you take log of 5, close the parentheses, divide it by log of 4, close the parentheses, and we get an approximate answer. Because we need to round, we need to write the approximation sign of 2.161. And that is our x. Now when you plug that back in to double check it, because we rounded, you won't get an exact answer, but you will get something very, very close. Now let's do the equation 3 to the 2x is equal to 27. 27 is the same as 3 to the third power, so we can go ahead and replace that. We can make these the same base using our first technique. So we'll have 3 to the 2x is equal to, we replace the 27 with 3 to the third because they're the same. Now we can get rid of our base and set 2x equal to 3 and divide both sides by 2, which gives us an x equal to 3/2 or 1.5 if you'd like to write it as a decimal. For our last example, solving exponential equations, we're going to do 2 to the 3x equals 15. 15 cannot be written as power of 2, so we have to take the log of both sides using our second technique. So log of 2 to the 3x equals the log of 15. Now we have to take our exponent and move it to the front, so we get 3x log 2 equals log of 15. Divide both sides, and here I can do one step together. We can divide 3 and log of 2 at the same time. We could do them as separate steps, but we can do them as one to make it just a little bit shorter. So we can cancel the 3 and the log of 2 to get x equal to log of 15 over 3 log of 2. We can put that in the calculator, log of 15 parentheses divided by 3 times log of 2 close parentheses, and that's going to give us an x of approximately 1.302. Again, we can plug that in to check, but do remember that because it's an approximation, it won't come out exactly, but it'll come out very close to 15.
A logarithmic equation is an equation with a logarithmic expression that contains a variable. You can solve logarithmic equations by using the properties of logarithms. The first thing we want to do is always combine everything into one logarithm. Just like with radicals, we also want to get the logarithm on one side by itself, get rid of all of the other extra numbers. Then we want to use the base of the logarithm and raise both sides as the exponents. The last thing we need to do is, just like in rational and radical equations, we need to check for extraneous solutions. Sometimes you will have an extra solution that makes the function undefined.
Here we're going to solve the equation log base 6 of 2x minus 1 is equal to negative 1. We already have the log by itself, so we're going to raise both sides as an exponent with base 6 because that's the base of our logarithm. So we have 6 to the log base 6 of 2x minus 1 is equal to 6 to the negative 1. 6 to the log base 6 cancels, leaving us with 2x minus 1 equals 6 to the negative 1. Remember, a negative exponent puts the number into the denominator, so we get 2x minus 1 equals 1 over 6. We add 1 to both sides, which gives us 2x equal to 7/6. I get 7/6 from 1/6 plus 6/6, which is the same as 1, which gives me 7/6. Last thing we do is divide both sides by 2, where we get x equals 7/12. Now we're going to solve the equation log base 4 of 100 minus log base 4 of x plus 1 is equal to 1. first thing we want to do is combine the logs into one log. Since we're subtracting them, we're going to use the quotient rule. So we have log base 4 of 100 divided by x plus 1. And that's equal to 1. Now we go ahead and take that and put it a base 4 on both sides. So we get 4 to the log base 4 of 100 over x plus 1 is equal to 4 to the first. Now I know that the left side looks very complicated, but we're going to go ahead and cancel this so that we just get 100 over x plus 1 is equal to 4 to the first, which is 4. Now we can make 4 into a fraction and cross multiply. 100 times 1 is 100, and that's equal to 4 times x plus 1. We distribute the 4, which gives us 100 equal to 4x plus 4. Subtract 4 from both sides to give us 4x equal to 96. And divide both sides by 4, which gives us a final answer of x equal to 24. For this example, log base 5 of x to the 4th equals 8, we're using the power rule. So we're going to bring the 4 into the front of the equation. So 4 log base 5 of x is equal to 8. We can divide both sides by 4. To get log base 5 of x equal to 2. Now we have to raise both of these as exponents with a base of 5, because that's the base of our log. So 5 to the log base 5 of x is equal to 5 squared. The 5 log base 5 cancels, leaving us with x equal to 5 squared, or x equal to 25. Here we're solving the equation log base 12 of x plus log base 12 of x plus 1 is equal to 1. Since we have addition, we're using the product rule, so we're going to put them together by multiplying. So log base 12 of x times x plus 1 is equal to 1. Now we're going to use base 12 because that's the base of our logarithm and raise both of these as exponents. So we have log 12x times x plus 1 equals 12 to the first. Again, our 12 to the log base 12 cancels, and we get x times x plus 1 equals 12 to the first, which is just 12. Now we need to distribute our x. So on this side we get x squared plus x minus 12, putting the 12 on this side, is equal to 0. Now we need to factor, so we need to multiply to negative 12 and add to positive 1. So we'll get x plus a 4 and x minus 3 equal to 0. We set both of these equal to 0. X plus 4 equals 0, and x minus 3 is equal to 0, and solve both. This one will be x equal to negative 4 by subtracting 4 from both sides, and this one will be x equal to 3 by adding 3 to both sides. Now we have to go and double check them. So using the first one, we're going to plug in x as negative 4. So we get log base 12 of negative 4 plus log base 12 of negative 3 is equal to 1. Now here, the problem is that log base 12 of negative 4 is undefined. Since this is undefined, this cannot be a valid answer. So we have to cross out negative 4. Now we can try 3. We get log base 12 of 3 plus log base 12 of 4 equals 1. And we're getting this 4 by plugging in 3 and adding 1, and that's where the 4 comes from. We can go ahead and simplify this into log 12 base 12, because this is going to be 3 times 4 using the product rule. So log 12 of 12 is indeed 1, so that's a correct solution. So our final answer is x is equal to 3, x is not equal to negative 4.